Okay, so our next topic is integration. So there's a past question. That was 2023, 2024. Question 4. So what I'm going to do is I'll first give an overview about the topic, which is integration, before we solve the past question. So with integration, most of the time students get confused with integration and that of differentiation. So this is integration, this is differentiation. Take note, this is what we are dealing with, not differentiation. So assuming integration, I have y is equal to 2x squared. Differentiation, to have y is equal to 2x squared. With integration, dy respect to dx. This is 2x. With integration, the exponent, we add 1. So 2 plus 1. So I'm having 2x cubed. Then the next thing we'll do is, with our new power, which is the 3, we divide everything here by 3. This is how we do with integration. With differentiation, this is the y over the x. With differentiation, this is 2x. You subtract 1 from the exponent and multiply the whole thing by the exponent. So this 2 came in from this is minus 1. So this gives us 4x. We don't have exponent 1, so 4x like this. Now with the same integration, if I'm integrating just a number, this side I'm differentiating just a number. This side with integration, just a number. So dy over the x. With integration, we just add a variable. If it's x, and x. If it's q, then a q. But with differentiation, just a number becomes 0. With integration, assuming, sorry, let me not use this here. Let's do something like this. Because since it's integration, this is a sign for integration. So let's not do this. Let's do this way. Let's assume with integration, we are told to integrate. That's question 1. This is 2. We are told to integrate this. That's how we do it. If you're integrating just a number, we add a variable. If x, x. If q, q. When you're differentiating just a number, which is 3, so dy over dx, this is equal to 0. When you're integrating just a variable, let's assume you have this. You've been asked to integrate this. This is what we do. You know integration, any variable already has an exponent of 1. We are adding 1. So plus 1, we have x squared. Then the next thing we'll do is we divide everything by the new power. So divided by 2. So this is the final answer. This is integration. This is differentiation. So now, let's focus on what we are doing. Integration. Now with integration, we have indefinite integral. Then we also have definite integral. Okay. So I'll pick this one first, the indefinite. The indefinite integral. So let me just give an example. Let's say 1. We have this. This is 3x plus 2. This is the x. We'll be asked to integrate this. This is what we do. This is 3x. You know integration plus 1. It already has an exponent of 1. So plus 1. This is plus 2. Whenever you are integrating just a number, we add a variable that is common in the question, or a variable that is being used in the question. So the question is using x. So I'm integrating 2. So I just add a variable to it. So remember, this side is 3x squared. Take note, with integration, once you get a new power, you divide everything by the new power. Plus, this is 2x. So this is how we integrate this question. Question 2. We have 4x squared. Let me do the 6x squared plus x. We are integrating this as well. So this is 6x integration. It already has an exponent of 2. We add 1. Any variable standing alone has an exponent of 1. We are adding 1. So plus 1. So this gives us 6x cubed. Remember, integration, we divide everything by the new power. So divided by 3. Plus, this is x squared. We divide everything by this new power, which is this. So I'm having 6x cubed divided by 3 plus x squared over 2. Take note, 3 can cancel this 2 times. So we have 2x cubed plus x squared over 2. Take note, you can't cancel this and that unless there's a 2 here. Then you cancel this and this. But it wasn't like that. This is the correct one, like this. So you can't cancel. So this is the answer. So this is how we deal with indefinite integral. Now, whenever you are solving an integration question, when you get your final answer, assume with this was our answer. We add plus c. We call this the constant term. It's a rule. We always add a plus c or a k to what? The final answer we are going to get. So for this, it becomes plus c. Because we have what? A constant term. It's a rule. So this is how we deal with indefinite integral. So now let's move to the definite integral. Then we now solve our question. Okay, so we are done with the indefinite integral. So we move to the definite integral. So with the definite integral, let me pick a question. We have this. This is 1. This is 3x plus 1. This is dx. Now, what we have here is what we are integrating. So we have, this is 2, this is 1. This is x. You know every variable has an exponent of 1. Integration, we add plus 1. Any number, we just add a variable. It depends on the variable the question is using. So the question is using an x. So I just add x, but we don't have one x. So it's just x. This is the x. So this side is, this is 3x. Remember, this is 2. Per integration, we divide everything by the new power. This is 2. This is plus x. So we have this. Now, we're given a superscript of 2 and a subscript of 1. So what then do we do? So this is what we do. When x is equal to 2, the first one, we have 3x squared plus x. This is over 2. So we know x. So this is 3. This is 2. This is squared. 2 plus 2. Let me use the calculator. So 3 times 2 squared divided by 2 plus 2. This will give us 8. So we have 8. So we are done when x is 2. The next one, when x is 1. So I have 3x squared plus x over 2. So now x is 1. So this is 3. This is 1 squared. This is over 2 plus 1. So 3 times 1 squared divided by 2 plus 1. This will give us 2.5. So this is how we solve definite integral. So let's pick another question. 2. Let's assume we have this. This is 3. This is 2. I have 2x plus 4 plus 3x squared. This is dx. So let's solve this one as well. So what's in the bracket is what we integrate. So I have this. This is 2. This one will give me 2. And remember, an exponent of 1 plus 1 squared divided by 2. I'm doing it straight away since you guys already have the concepts. So this is plus. Any number, we just add a variable, so 4x. We already have an exponent of 2 integration, we add 1. So we have 3x what? Cube. We divide everything by the new power. This is 3. This is the x. So this cancels that. So I have x squared plus this is 4x. This moves that. So I have plus x cubed. So this is our integrated what? Equation. Now, when x is 3 and 2, so the first one, this is x squared plus 4x plus x cubed. Now, when x is equal to 3, the first one, 3, we have x squared plus 4x plus x cubed. So x squared, this is 3 squared plus 4 times 3 plus 3 cubed. So we have 3 squared plus 4 times 3 plus 3 cubed. This is 48. So now we are done with this one. When x is 3, now when x is 2, we have x squared plus 4x plus x cubed. This is 2 squared. This is 4 times 2 plus 2 times exponent 3. So 2 times 2 into bracket 2 squared plus 4 times 2 plus 2 cubed. This will give us 24. So mostly this is how we do. We can even form coordinates from here. So meaning when x is 3, y is 48. You can form coordinates. When x is 2, y is 24. In the previous ones, you can still do the same thing. When x was 2, y was 8. When x was 1, y was what? 2.5. So that's all about definite integral and indefinite integral. So now let's move straight to the question you are about to solve. Okay, so there's the question. There's 2023, 2024, question 4. So A, evaluate the indefinite integral. So A, so this is my solution. So A, we're given an indefinite integral. So the indefinite integral, we have this. There's a symbol or a sign for integration. So this is 3x minus 5. This is square. This is dx. Now, what we have here, we are supposed to integrate it first. But because of the square, we first have to solve this. So this is how we do it. Now, it's mean square, so meaning twice of this. So I have 3x minus 5. 3x minus 5. So the first one will multiply the whole of this. So I have 3x times 3x minus 5. The next one will also multiply the whole of this. It's minus what? 5. This is 3x minus 5. So we expand this. This will give us 9x. 3, it's xx, so x squared. 3 times 5 is 15x. 5 times 3, negative 15x. It's negative here, so negative. 5, 3, 15x. Minus, again, would give us 4. So 5, 5, 25. So now we have 9x squared. This gives us minus 30x plus 25. So this equation is what, so this is what we integrate. So this is what we are rather going to integrate, but not what was given in the question. It was given in terms of squared. If it do, you will still come and get this equation here. But this is the simplest way to do it. We are saying it's squared, so meaning twice of this. So expanded. So we are having this. So this is what I'm going to integrate. So I have this here. This is 9x squared minus 30x plus this is 25. This is the x. So I integrate this. This will give me 9x s squared, so plus 1. So exponents 3. Divide everything by the new power. This is minus 30. This is x. It already has an exponent of 1, so plus 1. So we have squared. Divide everything by the new power. This is the new power. Just a number. We add a variable. Which variable is the question you're using? The question is using an x. So this is x. So this goes here 3. 2 goes here 15. So I have 3x cubed minus 15x squared plus 25x. So this is my final answer. So this is what we were asking you guys to solve for, the A part of the question. So we move to the B part of the question. So this is all for the A part. So this is our final answer. There's it. So we move on to the B part. Okay, so with the B part of the question, the demand and supply functions of a good. This is the application type of integration. So the demand and supply functions of a good are given by P is equal to 300 minus Q squared D. P is equal to 100 plus Q squared S. Where P, QD, and QS denotes price, quantity, and quantity supplied respectively. I, calculate the equilibrium price and quantity. I, calculate the consumer and producer surplus at equilibrium. So this is the solution. This is the B. So we have equilibrium price and quantity. Now most of the time students ask, how would you be able to differentiate between an application type of integration and that of demand and supply, since they both ask the same question? The difference is with the integration type, they have squares in it, but with the normal demand and supply, we don't use squares. So that's the difference. So let's move straight to this. So assuming it was a demand and supply, I would have used QD is equal to QS like this. Here lies the case you are dealing with what? Integration, because they have what? Squares. Their exponents are squares, or it has an exponent. So we are not going to use this formula. We rather use P is equal to P like this. This is the rule we use. So P, the first one is 300 minus Q squared D. This side is 100 plus Q squared S. Now, since we are equating price to price, meaning we are going to find quantities here. So what then do we do? With this D, I'll eliminate this D and eliminate this S to make all the same variable. So we group like terms. So this is 300. Positive 100, you move it to the left hand side, it becomes negative 100. This is Q squared. You move this plus Q squared. This gives us 2Q squared. This gives us 200. We are finding for Q, not Q squared. So I divide both sides by the coefficient of Q squared, which is 2. This side 2. This is also 2. So I have this. So 2 goes here, I have 100. So 100 is equal to Q squared. I'm finding for Q. So what then do? I square root both sides to eliminate the squared here. So Q is equal to 10, square root of 100. Yes. So therefore, equilibrium, the equilibrium quantity is 10 units. Now, they said equilibrium price and quantity. We have quantity. So we move to equilibrium price. So equilibrium price, you can pick any of the price functions. They were all price functions. So the first one was corresponding demand price, because that was where we had the QD in it, the D, demand. So P, this is 300 minus Q squared. Q is 10. This is P. This is 300. This is 10 squared. P is equal to, this will give us 200. We try the corresponding supply price as well. Corresponding supply price too. P is equal to 100 plus Q squared, where Q is 10. P is 100 plus 10 squared. So this also gives us 200. Now, one thing about this integration is, once you get a quantity and fix it in either the demand or the supply, they are corresponding price functions. You are supposed to get the same price. In a situation whereby the price differs, then meaning you're automatically wrong. The price are supposed to be the same thing. So we move to the II part of the question. We are solving the B, but this is the I. We move to the II. So the II is talking about consumer surplus and producer surplus. Now take note, with the equilibrium price and quantity, since we are dealing with integration, that doesn't mean when you are finding the equilibrium price and quantity, with the functions being given, you are going to integrate this. No. With the equilibrium price and quantity, always this is how we solve it. But the II, where we have the consumer and producer surplus, that is where we deal with the integration, but not this side. This side we don't integrate it, because we want quantity and what? Price. But the consumer surplus and the producer surplus, this is where we deal with the integration. So, consumer surplus, CS. This is the formula. I have a demand function here. This is the X minus price times quantity. So this is consumer surplus. So I have this. The demand function. This is the demand function, because there was a D here. So this is the demand function. So 300 minus Q squared. So I have this. 300 minus Q squared D. This is dx. We don't bring the D here. So we do it this way. Minus price. Price was 200. This is 200. Times quantity. We had 10. This gives us 2000. So this is what we are going to integrate. So just a number, we add a variable. Depending on the variable the question is using. So we have 300. We have 300 Q minus, this is Q squared. Remember, integration, we add plus 1. So this is Q cube. What then do we? We divide everything by the new power. So this is over 3. So we know our Q to be 10. This is 10. We substitute it into there. So this is 300 times 10 minus 10 cube divided by 3 minus 2000. So consumer surplus is equal to, so I have 300 times 10 minus 10 cube divided by 3 minus 2000. You're getting 666.67. That's our consumer surplus. So we move on to the producer surplus. So this is producer surplus. So the formulas alternate. This is consumer surplus. So with producer surplus, if I have PS here, this side is a demand function. So with producer, it starts with price times quantity minus the supply function. This is dx. So now, this side is price was 200, quantity was 10, minus, we have this, the supply function is here, we have an S here. So this is our supply function. So 100 plus Q squared, 100 plus Q squared. This is the X. So this side is giving us 2000. So we have this. So this is what we are going to integrate. So just a number, we add a variable, so 100Q plus, it already has an exponent of 2, integration, we add 1, so this is Q cube. What then do? We divide everything by the new exponent, so this is 3. We have dx. So now, Q is equal to 10, so I have px here. This is 2000 minus, I have 100 times 10 plus, this is 10 cube over 3. So producer surplus is equal to, let me do it on the calculator. It's the same thing, 666.67. So that's how we solve the producer surplus. And that's how we also solve what the consumer surplus. So one is it always that we are going to get the producer surplus and that of the consumer surplus to be the same answers? No. It was just this particular question that is happening this way. But most of the time they vary. So this is how we solve the consumer surplus and the producer surplus. So this was 2023, 2024 past question. So we'll try and solve a different question or a different past question as well.